Hi friends, in this session we study about the limits. First I would like to explain why the limits are required. So here you see there are so many circles I have drawn here already. These all the circles are of same radius, having same radius all the circles. So the area of all the circles are same, are equal. So the circles of equal areas I have drawn here. You see one more thing, there is different regular polygons inscribed in a circle. So here in first circle you see there is equilateral triangle, in the second circle you see there is a square, and the third circle you see there is a pentagon and there is hexagon. These are the regular polygons are there, regular pentagon and regular hexagon. Look at here, difference between the area of circle and the area of polygon we have to find out. The difference, which is denoted by d, and n is the number of sides of a polygon. Area of circle minus area of polygon. The area of polygon we are denoting by small n. N is the number of sides, a n we are taking as an area of the polygon. Here you see, if we have an area d3, we have to find out here. If you put here d3, if you put here d4, if you put here d5 is the area, the difference of the area between the circle and the polygon. Here d6. So look at here. So the area, this area, I am talking about this area. The difference of the area of circle and the area of polygon, this area, and here you see it is this area I am talking about. Here this area I am talking about, and here this area I am talking about. This area. So this area is d3. If n is equal to 3, if there is an equilateral triangle inscribed in a circle, so it is greater than the area of d4 inscribed in a circle. You see the difference between this circle and this square is smaller than the difference between this equilateral triangle and this circle. If we take d5, then you see it is also smaller than d4, the difference d4. It is also smaller than d6, is smaller than d5. In this way, if we take d10, it is smaller than this. And if we go to infinite, if we take the number of sides infinite, so what would be the difference? If we take and the number of sides of the polygon is infinite, then the difference would be, if we take n tends to infinite, if n is equal to infinite, then what would happen? We have to find the limit. We cannot reach at the infinite, but we tends to infinite, we approach to infinite. One could approach to infinite, but what cannot reach at the infinite. So if we n tends to infinite, then the area of this polygon should equal to the area of this circle, because the number of sides is approaching to infinite. Then so the area of circle and the area of polygon are same, then the difference would be 0. Here I would like to explain the limit here. It's very pretty way to explain this way. So the limit n tends to infinite here for d, for the difference which is dn. If we put here infinite, then we get 0. So the difference is 0. Difference of the area of circle and the area of polygon is 0 if n tends to infinite. So this is, it shows us the requirement of limit, why the limits are required. We are approaching to that point, but we cannot be at that point. So we need a limit to find out. So now we see another numerical problem based on limit. Now you consider the function f of x is equal to x square minus 4 over x minus 2. Here it is a rational function. In the rational function, the denominator should not be equal to 0. So because x minus 2 should not be equal to 0, therefore x should not equal to 2. If we put here 2 in the denominator, what will happen? If you put 2 in the numerator and denominator, we see what happens now. So I put here, it is 2 square minus 4 over 2 minus 2. I get here 4 minus 4 over 0, which is 0 over 0. It is an indeterminate form we are getting here. If we put 2, look at here, 2, 0 by 0. So it means, however, if x is not equal to 0, then we could solve this another way. So I try to solve. If f of x, we need some place to explain this. So f of x is equal to x plus 2 into x minus 2. And in denominator you see that it is x minus 2. Look at here, x square minus 4, which is equal to x square minus 2 square. Now we apply the identity of a square minus b square, which is equal to a plus b into a minus b. So we are applying this identity here, x plus 2 into x minus 2 over x minus 2. So now what happens? We see here, they eliminate to each other, it cut each other. Now, so f of x is equal to x plus 2 we have now. So now in this table we put value close to 2 from left and the right side, both sides. We see we approach these values here. If I put here in this table 1.4 and I put 1.4 here, f of x is equal to x plus 2. So 1.4 plus 2, that is 3.4 now. I am getting here 3.4. If I put here 1.5, then see what happens now. It is 3.5. If I put in 1.6, it is 3.6. 1.7, it is 3.7. 1.8, it is 3.8. Finally 1.9. Here I get 3.9. And if I put 1.99, then what happens here? 3.99. So if x approaches to 2, if x approaches to 2, the f of x approaches to what? 0 over 0 here. Okay, indeterminate form. So we see here. Now from the right side we see here. So the right side 2.6 we are putting here. So we get, if we put here 2.6, 2 plus 2, 4.6. Now 2.5 we are putting here. So it is 4.5. If we put here 2.4, it is 4.4. If we put here 2.3, we get 4.3. If we put 2.2, we get 4.2. If we put here 2.1, then we get here 4.1. Now finally, if I put here 2.01, so we get here 4.01. So you see here, we are approaching from the right side, we are approaching from the left side. If it tends to x tends to 0, the limit of this function would be from the left side and the right side. We have to see. We use the notation. I explain you now in detail again. We are approaching. We are not on the point at 2, but we are approaching to 2 from the left side and the right side. And we see the limit exists or not. So here we see how the limit we have to find. If we are approaching from the left side, so it is called left hand limit. So left hand limit, first we find out. Left hand limit, from this side we are approaching, and we are taking very small difference between 2 and x, between where we have to approach, between that point we are taking very small fraction over there, that is denoted by delta x or y. H, we could write here h also. So Now I write in this way, limit, we have to find out the limit x tends to 2 from left side, if we say, or we take a very small fraction left side of 2, which is h. So we could write that x is equal to 2 minus h is a very teeny, very small fraction left side of h. It is very small. So 2 minus h. If x tends to 2, if x tends to 2, then h tends to 0, because h tends to 0 if x approaches to 2, then h approaches to 0. Now here you see x tends to 2 negative. 2 negative, it means it is left side of that 2. So we have function x square minus 4 over x minus 2. Now we see how it happens. So instead of x, we have to put here 2 minus h. So I put here limit x tends, instead of x we are putting 2 minus h, or so h tends to 0, we have to take the limit here. So limit h tends to 0 for 2 minus h whole square minus 4 over 2 minus h minus 2. So here you see limit h tends to 0. Here I make the square, whole square of this. I am putting the identity. Here we have to apply the identity a minus b whole square, a square minus 2ab plus b square. So we will apply this identity here. So it is 4 minus 4h plus h square minus 4. In the denominator you see it's negative 2 and it is positive 2. So both will eliminate to each other. Now in denominator we have only minus h. Now limit h tends to 0. We see what happens now. So here also in numerator you see here 4 is positive, here 4 negative. Now here minus 4h plus h square, we can take h as common. So it is, I could write in this way, h minus 4. In denominator there is minus h. Here you see it again eliminate to each other. Now h minus 4 over minus. So limit, if we put here h tends to 0, so then minus 4 over minus 1. If we put here 0, so it is 0 minus 4 over minus 1. So which is 4. The limit for the left hand limit of this function x square minus 4 over x minus 2 is 4. Now we could find out the right hand side limit for this also. So if we approach from the right hand side, what would happen? We are taking the same fractional part of that approaching to 2. Now we see the right hand limit here. From the right side we are approaching to 2. So for this, what we have to take, x is equal to 2 plus h. It means if x tends to 2, then h tends to 0 here also. So now we can put here limit x tends to 2 positive. It is from the right side, so we put here positive sign. So here instead of I am just putting here x minus 4 over x minus 2. Now what we have to do here? Now limit we are putting, instead of x 2 plus h, so we have to take the limit h tends to 0. So here I put here 2 plus h whole square minus 4 over 2 plus h minus 2. So we simplify this, h tends to 0, here a plus b whole square identity we will use here. So we get here 4 plus 4h plus h square minus 4, and here 2 and 2 eliminate to each other. So look at here, this 2 and this 2. will eliminate to each other. Here we get h only. So limit h tends to 0, here also 4, you see, look at here, this 4 will eliminate to each other. So here we are taking h common, and here 4 plus h we have now, and denominator there is h, and h will cut each other. Now we have h, 4 plus h. If we put the limit h is equal to 0, if we put h is equal to 0, 4 plus 0, which is equal to 4. So 4 is the right hand side limit, we have 4, and the left hand side limit is also 4. So the limit of this function is 4. Okay, if you put the value here too, after factorizing the numerator and simplify, then we put the limit, so it is 4. So the function value, if we have to find out the function value, whenever we have to find out the function value f of 2 or f of a, whatever is given, so then we get the function value 0 over 0, which is indeterminate. In this way, the requirement of limit we know. Now we see the difference between the value of a function at a point and the limit at a point. We see now, let f of x be a function and let a be a point, then we have the following possibilities we will get here. So there are 4 conditions: difference between the value of a function at a point and a limit at a point. There may be first condition. If first condition would be limit f of x, x tends to a, exists but f of a does not exist. Here you see the same problem we have done first, x square minus 4 over x minus 2, where the limit exists, limit is 4, but the function value is not. So I explain here again. The same process, the left hand limit, right hand limit, we have to find out here, but I directly find out the limit. I am not using the left hand right hand limit formula, just I am direct factorizing it and find out the limit here. So we have the different methods I would explain in the next session. First we find out the limit. X tends to 3, we have to find out this limit, x tends to 3. So we have a function x square minus 9 over x minus 3. So look at here, limit x tends to 3, we are factorizing the numerator, so x plus 3 multiplied by x minus 3. So we are getting here, in denominator we see that there is x minus 3, and if we simplify this, the x minus 3 and x minus 3 will divide each other. So now we see limit x tends to 3, here x plus 3. Now if we put the value of limit, whatever is 3, we put here 3, so we get here 3 plus 3, which is equal to 6. So the limit of this function is 6. But if we have to find out the function value, now we have to find out the function value, f of x is equal to x square minus 9 over x minus 3. So we have to find out the x3 here. So 3 square minus 9 over 3 minus 3, which is equal to 9 minus 9 over 0, which is equal to 0 over 0, which is indeterminate form. So the limit exists, limit is 6, but the function value does not exist. Here you see this position. Now the second one, we see the value of f of a exists, but limit f of x, x tends to a, does not exist. So we see how it happens. Let me take one example. F of x is equal to greatest integer function of x. So you know that already in our previous sessions we have studied about the greatest integer function. If there is a value 3.9, the greatest integer function would be 3. So in this way, if we approach x tends to 3, so we see what happens from the left side and the right side. So LHL we take here, LHL we take here. So we see what happens now. Limit x tends to 3 from left side, greatest integer function of x. So here what we have to put, it implies to x is equal to 3 minus h. If x approaches to 3, then h tends to 0. So here we have to write in this way. Limit h tends to 0. Here we have to put that 3 minus h instead of x. Now we see what happens. 3 minus h. H is a very teeny fractional part of a number. So if 3 minus h, we assume that it is 0.01. So we get here 2.99. So it is 2.99 now. So we get the greatest integer value of 2.99. Whatever the 2 point something, we get always 2. So the limit would be 2 for this. Now we see the right hand limit. Look at here again. Limit x tends to 3 plus for this integer function, greatest integer function, sorry. So the limit, I explain you here one thing more for that. If x tends to 3 positive, so you have to write x is equal to 3 plus h. If x approaches to 3, h tends to 0. So here we are putting that h tends to 0 now. For this function, we have to put instead of x 3 plus h. 3 plus h, we are very fractional part, we are adding with 3. So get here, if I adding 3 plus, it is a little bit fractional part 0.01 here, we are adding. So we are getting 3.01. So 3.01 for greatest integer function, we get 3. For this, we get 3. So here we are getting 3. So the left hand limit and the right hand limit both are different. Both are not same here. 2 is not equal to 3. So limit does not exist here. But the function value, if you have to find out, f3, you have to find out, then greatest integer function of 3 is equal to 3. The function value exists, but the limit does not exist in this way. Now we see the third one. Limit f of x tends to a and f of a both exist but are unequal. They are not equal. So here you see the function f of x is equal to x square minus 4 over x minus 2, where x is not equal to 2. Here we have to find the limit, left and right hand limit we have to find out here. And if x is equal to 2, it is 3. It is given to us. So we find out the value of limits left and right and the limit exists or not. The limit exists here, but I directly find out the limit. So limit x tends to 2 for x square minus 4 over x minus 2, then limit x tends to 2, it's x plus 2 into x minus 2 over x minus 2. You see here the x square minus 2 square, which is x plus 2 into x minus 2. We have applied the identity a square minus b square is equal to a plus b into a minus b. So here you see now. So this eliminate each other. Now limit x tends to 2 for x plus 2. If we put the value of 2 here, 2 plus 2 is equal to 4. The limit of this function is 4. Now the function value f of 2 is given 3. So this value and this value are not equal. The limit exists, but both things are exist, but they are not equal. The limits and the function value both exist, but not equal. Now we see the next one. This is the last one. We have the limit f of x tends to a and f of both exist and are equal. So as we have seen in the previous, we have seen that the limit is 4 here. So here the limit is 4. Limit, we know that limit for it is equal to 4, and the function value is also 4. They are giving that f2 is equal to 4. So both exist and both are equal. So we have here we have seen that the 4 ways the difference between the value of function at a point and a limit at a point. So we have seen here the possibilities, how many possibilities were there. We have seen there are 4 sort of possibilities where the limit exists but f of a, the function value, does not exist. Where function value exists and the limit does not exist. Where the function value and limit both exist but are unequal, and where the limit and the function value both exist and are equal. So we have seen this. Now we see how to make the graph of this limit, how it's expressed on the graph. So we know that f of x is equal to x square minus 4 over x minus 2. Here, if I put x is equal to 0, then see what happens now. So 0 minus 4 over minus 2, 0 minus 2, so that is 2. So at 0 you see there is a point to x is equal to 0, and then y is equal to 2. Now we are getting one more point. If we take x is equal to minus 2, you see what happens here. F of minus 2. In the numerator you see minus 2 square minus 4 over minus 2 and which is equal to 4 minus 4 over minus 4, which is 0 over minus 4, which is 0. So if x is equal to minus 2, then y is equal to 0. Here you see. So here y is equal to 0 and x is equal to minus 2. So these 2 points we have got here. Now we draw a line to this and see what happens first. I just draw this line and in a proper way first. Manage it. This is our line for this function. I change the color for this line also. So this is our line here. But at 2 we have to see what happens at 2. So I just x is equal to 2, you see it's I put here some it is x is equal to 2. The function does not give us any value here. If we approach from this side we get here. If we approach from this side we get here. It is x is equal to 2. So I put one line here also, a white color line I put at this point. Look at this. Just a minute. Is a point. It is x2 we are getting. It is x2 we have. So the left side we are approaching here, we are going nearer and nearer to 4, and from the right side we are 4.6, 4.5, 4.4, and we are coming to this place, but x is equal to 2, we are getting 0 over 0, but the limit is 4. So we have seen that already. So in this way you could draw the graph for this sort of function. So this is a way to represent. If we approaching to 2, x tends to 2, then f of x would approaches to 4. So from both the sides. Okay. So this way you could verify. Thank you.